Hello everyone and welcome to this latest webinar from IHS Markit titled Intelligent Optical Networks, a look into the future. Today our panel will explore how optical networks will be managed and operated in the future and address the opportunities, challenges, and emerging solutions for intelligent optical networks as a new foundation to deliver modern transport services. Our webinar is co-presented by IHS Markit and our partners Ciena, Fujitsu Network Communications, and Infinera. My name is Alan Tatara, Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we get started, I want to highlight just a few features that are available for you and also how you can participate in our webinar today. So the console that you're looking at is completely customizable. So this means you can open, close, move, or resize any of the windows that you have open on your screen and arrange the console as you wish. Now you're going to notice a number of application widgets at the bottom of your screen. These contain additional features that are available for you. So make sure you check these out during the webinar. A few buttons I want to mention. One is the resource list widget, and this is where you're going to find additional material about today's topic, including the downloadable slide deck from today's session, as well as other valuable resources, including a special report from our own analyst, Heidi Adams. And all these materials can be accessed and downloaded right from your console, so please take advantage of these during the webinar. And we do want to make this an interactive session, so we've included a Twitter widget at the bottom of your screen, which means you'll be able to tweet directly from the console. And today we're using the hashtag Optical Networks. We will also have a live Q&A session directly after the presentation, so we ask you to submit your questions or comments at any time by using that Q&A box on the left side of your screen. And if you encounter any technical issues whatsoever during the webinar, just click on that question mark widget and you will receive the answers that you need. So now let me take this opportunity to introduce our panel. First leading our discussion is Heidi Adams. Heidi is Senior Research Director in the Transport Networks segment at IHS Markit. Also joining us is Helen Zenos. Helen is the Director of Portfolio Marketing at Ciena. We are also joined by Man-Wing Fong. Man-Wing is a Strategic Solution Planner at Fujitsu Network Communications. And rounding out our panel, we have Mark Showalter, Senior Director of SDN Product Marketing at Infinera. So welcome to all of our speakers, and now let's get started with our presentation. So Heidi, I will pass it over to you.
Great. Thanks, Alan, and welcome to our attendees today. As Alan mentioned, our objective is going to be to have a look towards the future and what it's going to take to evolve towards more intelligent optical networks. So for today's agenda, we'll kick off with what our definition of an intelligent optical network is, and we'll look at some of the market trends that are driving us in this direction. We'll then have a look at some of the business and technical problems and challenges that we need to address to get there. We'll have a look at some of the new products, applications, and innovations that are starting to emerge in this area. And we'll have a look at some real-life use cases where some of these newer technologies are now starting, even today, to get introduced into optical networks. So with that as a little bit of an overview, let's get started. All right, so what is an intelligent optical network and what are intelligent network operations? So fundamentally, we define an intelligent optical network as something that brings together a range of technologies and solutions that ultimately enable this evolution towards more automated network operations. You may have also heard the terms autonomous networks and self-driving networks, and yes, these are also associated with the idea, but I personally see these as the ultimate realization or that far end goal of where we're heading with intelligent optical networks. So if you look at this slide in front of you, there's a couple of key things to take into account. We've got enablers on the left-hand side and where we're heading to, what the hoped for results and objectives are on the right-hand side. So starting off with the key enablers or those key ingredients to an intelligent optical network. These include flexible, adaptable, and instrumented network equipment, so starting deep into the network. And we're starting to see these capabilities coming to market through things such as transponders with programmable modulation formats. We've got different symbol rates emerging that enable, together with the transponders, more different wavelength capabilities and capacities depending on reach and fiber capability. We're also starting to see more network elements with the ability to provide streaming telemetry, which then can be applied into analytics applications. Leveraging this, we're also starting to see open network element models or abstractions that are defined to enable more centralized control across multiple layers and vendors. So you've got the flexible equipment layer, you've got the introduction of centralized visibility, control, and orchestration through the introduction of SDN into the network, and at the bottom layer of this cake, you also have a range of new SDN applications that are emerging to start leveraging these new capabilities within the network. So put this all together, what is it that we're trying to achieve? Well, there's three key new benefits, or they aren't new, the key ongoing benefits that we're driving to. How do you enable new revenues, which for optical networks really implies this transition towards more flexible and agile wavelength services, as an example, packet services as well. We're looking at CapEx reduction. How do you enable cost savings on the equipment side? This is critical, and we're starting to see this, or we will see this being achieved through being able to maximize and really fully utilize network resources. And finally, on the operational side, how do you start to reduce simplify operations to reduce operational expense, and we get there through more flexible network planning throughout a network's lifecycle, and also having more proactive network monitoring and maintenance moving forward. So put this all together, these are the enablers and the results for an intelligent optical network. So on the benefits or the results side of what we just saw, you don't have to believe what I say, but we do have some survey data that backs up what these key objectives are. And the findings are very consistent with what we've seen from a recent IHS Markit service provider survey that looked at transport SDN. This came out of our Packet Optical Strategies service provider survey. So we asked respondents to indicate what did they hope to achieve through implementing transport SDN into their networks, and asked them to rank drivers on a scale of 1 to 7, where 7 would be the most critical driver. So the chart in front of you, drivers for transport SDN solutions, this summarizes the number of times that we received a rating of a 6 or a 7. And you can see that the top driver is rapid service provisioning. And the next biggest one is operating networks with greater capital and operational efficiency. So very consistent with this overall vision of where we're heading to with intelligent optical networks. Of course, the next question then becomes, okay, so we've got the benefits, we want them, when can we have them? When will this be a reality? And if you look again at transport SDN as a leading indicator for what we need to get towards intelligent optical networks, let's look at this for timing as well. So from that same survey, we asked respondents to indicate when did they expect to start deploying transport SDN into their network. Just under 20% at 18% expected to make a start by the end of this year. You can see from the chart that momentum starts to pick up in 2018. And by the end of 2018, if this is the indicators are that probably around half the population will have started to introduce some SDN capabilities into their networks. And of course, there's a range of things that can be considered under that umbrella, and it doesn't necessarily imply everywhere in the network, but it is coming, and I think the key takeaway here is that close to 90% of the operators, at least of the ones we survey, do have plans to go in this direction. So this key building block is well underway. So before we move on, I want to reiterate one additional thing, is that intelligent optical networks are more than just SDN-enabled networks. Transport SDN is key and central element, but you also require the network itself to be seated, and I touched on programmable adaptable modems and the line system enhancements we require. And also, we also need a range of mature applications and analytics capabilities that can leverage these capabilities. So all this together is the intelligent optical network. So with this as background, let's go ahead and explore the next steps in our journey towards optical networks. And we're going to start off with some of the challenges that we face. And I'll hand this over to Helen Zenos of Ciena to kick us off.
Thanks, Heidi. Okay, so in the move towards intelligent dynamic networks that we're talking about, a key challenge that we need to overcome is that optical networks today are planned and built to be static over their lifetime. So they're not dynamic at all. They're really just designed to be static. They're designed using the planner's best guess predictions of what they think the worst case capacity requirements are going to be over the full lifetime of the network in fully filled past conditions. And to keep transport costs at a minimum, operators deploy application-specific hardware. So this means separate hardware for metro versus long haul, which also leads to different inflexible hardware that now they're going to need to standardize on. And once that hardware is deployed, the line rate has never changed, even though there may be enough system margin to allow for higher capacity in the next few years. So why has everyone been operating, in this mode? Well, basically, it's because we have not had the right technology and software capabilities to do things differently. Operators do not have real-time visibility of network performance or the right software tools to help them, best operationalize all the capabilities of the network in a much more dynamic fashion. So we keep running it in static mode. And if you overestimate the required capacity, this means you have equipment that is sitting idle in your network. And if you underestimate capacity, then your only options are to deploy new hardware and resort to network overbuilds. Hand it over to Mark.
Thanks, Ellen. At Infinera, when we talk with our customers, we find a lot of commonalities amongst the teams that are designing optical networks and facing the challenges of optical capacity engineering. If a service provider or network operator wants to activate a new service, they have to make sure there's enough capacity existing on the network already, and this process can take months. It starts by developing a forecast, basically collecting all the service requirements from the higher level applications, and then considering all the deals that are in progress or pending. And this creates a forecast, and that process can take a month, that then is turned into a bill of materials by looking at the different routes on the network, the different systems that are deployed, the capacity out there. The decision is then made, do we need to order new equipment? Do we not? And if we do need new equipment, then that can take a month just to get through the paperwork of ordering the new capacity from the supplier. And then depending upon the gear that's required, it can take another 2 months to be able to actually turn up and install that new capacity that enables this service to be activated. So this 4-month or more planning forecast window creates a big problem for service providers because they're going to lose business if they don't respond quickly to deals. Most opportunities come very quickly for service providers, and they're a very competitive environment. So they need to be able to respond quickly, and the way they do that is they over-provision capacity. Some carriers will provision up to 50% additional capacity on certain routes so that they can be ready whenever a new service requirement comes along. And this is exacerbated by the growth in 100 gig Ethernet services. So the challenge that we see that we're trying to address is how do we shrink this 4-month capacity planning cycle down to minutes. Over to you, Manwing.
Thanks, Mark. So based on the feedback we have been gotten from our customers, other than the ones that mentioned by Helen and Mark, there are a few additional challenges that they're facing today with their present mode of operations. Today's optical networks are built based on vendor-specific equipment. When building a multi-vendor networks often means that building a pockets of networks with specific vendors. With such a network, it's very labor-intensive to plan, design, and operate them. And it is hard to create services among these multi-vendor networks end-to-end. And there are lack of capacity optimization capabilities within the networks. Many service providers don't have a good consolidated network record and view to reflect the most current network usage and conditions of the networks currently. They plan the network usage to be optimal initially, but the network resources usage become less optimal over time. Lots of the network resources are being wasted, and lots of wavelengths and bandwidth is not fully utilized. That becomes one of the constraints to prevent the operators to grow the network in the rate they want, but needs to be within the finite budgets that they have. In addition, the way that they operate the networks today is highly reactive. The operators always see themselves in a fighting fire mode. When the alarm comes, they troubleshoot the networks. And many times, it requires highly skilled optical engineers and technicians to know the network well in order to troubleshoot these networks effectively. Otherwise, it is going to take them a long time to find the root cause and recover the networks from failure. Even with the skilled staff, in lots of times, it is still hard to predict how long it's going to take to find the root cause and recover from the failure. So the things that we have been constantly hearing from customers' feedback are the network must become more intelligent, efficient, and optimal. Back to Heidi, sorry.
Thanks, Menwing. Okay, so we just had a good summary of some of the challenges and where we're trying to get to, especially on the operational side. So now, what are the emerging options and solutions, or what are the new technologies that we're starting to see introduced? So just to frame the discussion, I'd like to share a little bit of IHS Markit's view of what we call the cloudified network automation cycle, and just frame the discussion we're going to have within this context. So we have a view here in front of you. This is a view of the various elements that are starting to merge to work towards this concept of intelligent optical networks. Although what I have here on this slide is applied in a much broader context. It incorporates not just optical, but also routing and switching, and has relevance across different network solution areas from mobile and fixed broadband to enterprise services and more. But still, there's a fundamental commonality here. So on the bottom, the little blue circle icons, this is representative of the network elements themselves and are instrumented in a more flexible network element, including optical equipment. In the gray boxes, you can see this emergence of domain orchestrators and controllers. Up a little bit higher, we have more of that centralized control and orchestration layer, and those applications that sit on top, and there's a very relevant one there to optical networking. That bandwidth on demand is certainly one that pops up a lot. But this isn't a static being. There is a feedback loop here, and I'll just pop up some of the build-outs in terms of how we gather network information, do some analytics on it, and provide some feedback and control to the system as a whole. So when you put that all together, this is what we call the cycle of automation. And as we go through the next section of the deck, you're going to hear some of the enhancements that are improving in different areas of this, from what we're seeing in the network elements to what we're seeing in SD and control to what we're seeing on the application side as well. So with that, I'll hand over to Menwing.
Thanks, Heidi. As Heidi pointed out, what we are seeing is that in order for us to get to a more intelligent networks and efficient optical network, the network architectures and the equipment needs to be updated. The network elements needs to be more flexible, more open, and SDN optimal. As the software needs to be more intelligent, as one of the things that I mentioned earlier, customers want to have a multi-vendor, multi-networks that can operate seamlessly together after they deploy. So the network architectures should have a machine learning capability that continuously learn from the networks by monitoring the setups and conditions of the network in a multi-vendor network environments. After all these data is being collected, you would like those data to be categorized, identified, and then analyzed, so that it can become useful information that is meaningful to you. Then this information can be applied by artificial intelligence to become more useful information. Well, it's translated and correlated into something that even more interesting, like predicting the future state of your networks, providing a suggestion of actions on how to run the network more efficient and optimal. That helps you more quickly to go through and to make a quicker and through decisions that used to take you days or even weeks by just sorting through the data. Sometimes the amount of data are so big that it's humanly impossible to go through. In the solutions front, there are several areas of focus that is important to service providers, and we have been looking into, like performance-aware control. With this area, it allows the users to create an end-to-end optical service path by a click of the buttons with their SDN controllers, and all the settings and optimizations are done automatically through the performance-aware control. The path will be set up based on the real-time network conditions, so that the path can be set up with the most reachable and highest data rates to push through. With capacity optimizations, it continuously monitors the network resources usage, such as wavelength allocations. Then it will self-adjust to ensure all wavelengths are being used in the most optimal way. Another area that is important is network health management. It proactively monitors the network health and conditions and continuously learn about the different failure scenarios so that all of these network failure experiences will be growth within the network over time. So how are these area of solutions can be applied to the future mode of operations to help us? With these area of solutions, service providers can build networks that will learn, analyze, optimize, and become more intelligent over time. With that, it gives more control to the service providers, more revenue control by efficiently and automate the network design and control so that an easier, faster network deployment that can translate into increased service and revenue velocities. And more CapEx control by optimizing the network resources usage so that the service providers can get the most out of their investment and grow the network in a rate that they want within the budgets that they like. And then more OpEx control by proactively operating the network with fewer dedicated optical experts so that the rest of the experts can spend the time to work on more important projects that help grow their business. Over to you, Helen.
Thanks, Minwing. So now I'll describe some technology enablers within the network itself that help and enable the network to become more dynamic. And Heidi mentioned this earlier, programmable coherent optics do provide the ability to remotely adjust capacity in the network on a per channel basis and without the need to deploy new line cards. So operators can leverage the fact, like how they do this is that prior to fulfill end-of-life conditions, there's some excess dBs of system margin in the network that they can leverage to be able to upshift the coherent modem to get more throughput and carry more services using the hardware that's already deployed in the network. If the coherent optics can be adjusted to a wider range of capacity rates, which is what we are seeing with higher baud rate modems becoming available in the market today, then the operator is able to better match optimal capacity to the available margin at any point in time. But coherent optics alone do not make the programmable network, as we've been talking about. Another key element includes the ability to understand via software exactly what the performance of the network is at any point in time. And hardware with extensive monitoring capabilities that can expose network performance data to a higher software layer is a key requirement. High-performance streaming telemetry to gather this data is also needed. This data can then be used to provide a deeper understanding of network behavior in real time, and then we're able to tune the network for optimal performance in all conditions. So here's an example of how an advanced software application can improve spectral efficiency for a link that is already fully filled with channels. An app called Power Spectral Averaging is used here with advanced per-channel optimization algorithms to extract more capacity out of the network. And on the left, we see a link using current best practice algorithms for wavelength deployment. And here, all the wavelengths are operating at 200 gig with lots of excess margin, but not enough margin to get to 250 gig. Using a power spectral averaging approach, the algorithm can figure out which channel powers can be increased and for which channels power can be decreased to provide the optimal capacity for this link. And in this example, a third of the channels were able to be increased from 200 gig to 250 gig, which translates to a 7% increase, translates to 145 more 10 gig services, which in turn means $100,000 of additional revenue if you're a wholesale provider. So all this is without having to deploy or pre-deploy new hardware and without having to resort to moving to a new fiber, which would have entailed basically deploying a new photonic line system. Over to you, Mark.
Thanks, Ellen. At Infinera, we like to talk about a concept called software-defined capacity. Software-defined capacity is different than software-defined networking, but similar. And the differences start when you look at the OSI model. Software-defined capacity takes this virtualization concept and the power of software down to layer 0 and layer 1. Traditional software-defined networking, as modeled with service orchestration and domain controllers, typically focuses on virtualizing layer 1 through 3 services within fixed wavelengths. And traditionally, capacity is deployed in advance, and then services are virtualized over that capacity. If the service provider wants to deploy new capacity, they typically have to roll another truck to be able to activate that capacity, deploy the capacity, and then activate the capacity. So in the software-defined networking model, what we see is a lot of overbuilding, where the customer needs to pay first for the equipment and then deploy it. And what we look to with the software-defined capacity model is to be able to use software to be able to change the amount of capacity in a network that has been deployed and only pay for the capacity as you activate it. So this changes the business model from overbuilding, where you pay first and activate later, to a business model where you activate your capacity and then you pay for it once it's been activated to enable those services. And this is done in a non-service affecting manner. The idea is to be able to leave on an existing fiber, all your existing customers, while turning on existing capacity and then paying for that additional capacity as you use it. So a very different business model overall than how things work with software-defined networking. Software-defined capacity extends software control all the way down to layer 0 and enables network operators to be more agile in how they respond to customer needs. So back to you, Helen, or excuse me, Heidi.
All right, so we just got a little bit of a touch there on some of the new solutions that are emerging from some of the different vendors in the market today. Let's have a look at how some of this technology is being applied in real-life applications, real-life customer use cases. So with that, actually, even before don't forget, if you have any questions, please do enter them into the console at the bottom of your screen, and we'll address those at the end of the session. So Mark, back over to you for instant bandwidth.
Thanks, Heidi. So at Infinera, we've been working on delivering concrete steps to our customers for some time. Started in 2012 with instant bandwidth, and our conversation today about software-defined capacity builds on this notion of instant bandwidth, which we've had in service since 2012 with a number of our customers. The fundamental idea is you pre-deploy equipment that has massive amounts of capacity, but you don't pay for that capacity until it's activated, and you're able to pay for that capacity through software activation of licenses. So in the initial model with instant bandwidth that we released in 2012, when the customer wanted additional capacity on a route, they would go to the license store, they would pay for the capacity to activate the license, and then the capacity would be deployed upon the network. And so what this enables is software control of additional capacity without affecting services on the network, and enables the operator to not over-provision as much capacity and pay for that capacity in advance. So instant bandwidth has been on the market for some time, software-controlled, software-defined capacity. And we've been very successful with this, with over 60 customers deploying this around the world. Instant bandwidth is the basis on which we see the next intelligent optical networks, the instant network capability being able to be deployed by service providers, builds on instant bandwidth. So let's now look at, as we look out in the future, how can software help enable automated capacity engineering and really accelerate the process of deploying services in the network. Here we're showing a service provider operational support system and a network between two metros, and we're considering a network that has an order placed between two metros by a customer. In this case, they're ordering a carrier Ethernet private line, 100 gig between the two locations. So that order will typically flow through a service provider service orchestration system through open APIs. In the case of carrier Ethernet, we typically see the Metro Ethernet Forum MEF55 LSO, Lifecycle Service Orchestration APIs, used to flow through information from service orchestration to multi-domain controller. In this case, the SDN controller is running an application called Automated Capacity Engineering. When the order flows through, the application knows the state of the network, it knows the capacity already deployed, it knows the additional capacity lying idle, waiting for activation, and then the software can then compute a route across multiple paths, and those paths can have different variables in terms of latency, cost, and weight, so that you're able to use the software to automate the route selection or the path selection for the optical wavelengths. And then this particular process, done in software, then talks to the software activation capability with the instant bandwidth and is able to turn on the licenses. And this capacity, again, is activated before it is invoiced. So then at that point, once the capacity is activated in this new model, the service provider is invoiced for the capacity after it's turned on, essentially turning the business model on its head and reducing the amount of over-provisioned capacity. The other thing that's possible with these licenses, essentially we have 3 different types of licenses that can be applied for capacity. We have movable licenses that can be moved from one piece of hardware to another, as well as time-based licenses that allow a lot of flexibility for network operators when building networks. So with that, over to you, Manli.
Thanks, Mark. So in Fujitsu, for an intelligent optical networks, we looked at the 3 solution area of focus: the performance-aware control, the capacity optimization, as well as the network health management. So based on these solution areas, that there are many specific applications that can be categorized within these areas of solutions. And those specific applications can be applied to the service providers' networks to help address the specific challenges that they have. For Mark and Helen has been mostly focuses on the area of performance-aware control solutions, the bandwidth-on-demand type of applications. So I'm going to spend a bit more time to discuss how the capacity optimizations and network health management applications can be applied to the service provider's network. In the bandwidth optimization applications, Fujitsu has built many algorithms that analyze optical wavelength allocations and network fragmentations. Network fragmentation is common to a network due to the remapping channels when fighting fire in an emergency, network mergers happens, human errors, and network wholesalers that require lots of customer trends. And lots of resources is being wasted and not fully utilized as a result. The bandwidth optimization should be vendor agnostic. And examples of performing a wavelength analysis would be, at first, the applications collects all the network information, such as network topologies, WDM channel plan, equipment placement, etc. Then it analyzes and it identifies all the network fragments, and it provides a defragmentation plan for the operators to review and take actions. As a result, many of the end-to-end wavelengths that were blocked due to fragmentations, and now it's recovered and the links can be used optimally. Now, another example that we have on the application is the failure predictions from the area of network health management. This is something that we constantly hear from our customers' feedback would be like, hey, I'm fighting fires every day. I have tons of alarms on the dashboard that I don't even know what to do with it and how to prioritize them. It is very, very hard for us to troubleshoot. With the failure prediction algorithm, it can help the users to continuously monitor and analyze the networks by collecting and correlating the data automatically based on the PMs, alarms, other network matrices. It can help the operators to accurately estimate the network performance and see how the current network conditions compared to what the normal state of the network it should be. Now, once have these detect any of these abnormal behavior, then we know that the network is in trouble. So then the prediction algorithm will then help to identify the root cause of the issues and find out what parts and location of the network is in trouble, and the estimated failure time is going to be. And once all of these have been identified, repair schedules can be put in place based on the predefined user policies and the current network activities, and plan accordingly. So we certainly don't want it to plan on a scheduled repair while there is a major activities, network activities going on and cause different issues. So in summary, all of these repairs can be planned ahead of time with a minimal downtimes instead of doing it in a last-minute failure fighting fire mode. Over to Heidi. Helen.
Thanks, Manweng. So I'm going to continue on the same topic as Manweng with some complementary information. And in this particular case, I'm going to be highlighting a real-world example of a Tier 1 North American operator using Network Health Predictor application. So this operator wants to reduce SLA penalties related to network downtime by 25% in the first year of deployment. So that's their very tactical objective that they want to meet. And so what we do here is take the past 2 years of historical network and OSS data, gather and feed this data into the analytics engine along with real-time network telemetry. The analytics engine then applies machine learning and trend analysis and identifies potential failures in the network. So using analytics, this operator is taking a step towards what we're talking about here, data-driven network automation and control with just-in-time network maintenance. So the analytics feeds the information to operations, which leads to maintenance activities being scheduled. And just-in-time maintenance means the operator is replacing things before they break, but not before they need to be replaced. And in this way, what they're able to get is a much more reliable network while still keeping costs low. And there's a second huge benefit of having this application. And here I'm focusing on the business benefits, but for anyone that has ever worked in a NOC and understands the extreme stress that's involved with all of a sudden seeing a whole bunch of red alarms going off that they have to decipher and troubleshoot, the emotional benefits for this group makes it really a game changer for their lives. Okay, I'm also going to cover a very forward-looking field trial on this topic of intelligent networks, and this was performed by Telstra, Ericsson, and Ciena in November 2015, so it's already a year and a half ago, and was presented at the ACOS event last September. So here we see SDN control applications are used together with programmable coherent optics to temporarily increase capacity in a live network using existing hardware that's deployed and carrying traffic. So very different approach to operating optical networks in the static mode that they're managed today. This type of use case is very relevant when planning for important political, sporting, or entertainment events where the service provider needs network capacity increased for a short period of time. And another outcome with this approach is now the ability to respond to unplanned service demands very quickly with the ability to turn up capacity on demand without ordering new hardware and without pre-deploying equipment that is sitting idle in the network. The trial was performed with Ericsson and Telstra's in-service terrestrial long-haul fiber optic production network between Melbourne and Sydney, Australia, so 1,100 kilometers. Flexible rate coherent optics were used, and SDN control applications were used to look at network performance, figure out how many dBs of margin are available for each channel, and predictive capacity can be increased. The application then remotely upshifted the wavelength capacity of one of the channels from 100 gig to 200 gig by changing the modulation. The key results of the trial was that for this network that had 4 channels deployed, a 25% increase in short-term network capacity was achieved using existing hardware that was in the network by using available system margin that is normally reserved to accommodate, the fulfill end-of-life conditions. There was no measurable impact on existing channels, which proved that it's suitable to use this approach for in-service systems. And the one thing I do want to note here, the trial was performed using optics that could tune into one of two levels, 100 gig or 200 gig. If we use coherent modems that can be tuned to a wide range of capacity options with small granularity, then you have the ability to better match optimal capacity to available system margin. And you can also see the importance of having the right software applications to make this possible. The ability to measure the margin at any point in time, perform the link engineering for different what-if scenarios and per-channel optimization. You have to push the right parameters into the network and coordinate between the multiple layers for appropriate handling of services. Over to you, Heidi.
Hi. All right. Thank you, Helen. Okay. So with that, just like to take a moment and have a word from each one of our sponsors. Clearly, each of them is doing some work in this area, and I'd like to give them an opportunity to share a little bit about their overall approach to that broader term of intelligent optical networking. So with that, I'll kick off. Helen, let's stay with you on this one first.
Thanks, Heidi. So after several years of customer demos and field trials at Ciena, we're very excited to officially announce our liquid spectrum solution this year in March, now that all elements are available in the near term. And liquid spectrum is all about combining programmable hardware with advanced software applications to change the way networks are operated moving forward and help our customers extract the most value of existing assets that they've already deployed. So it's about delivering agility and scale through programmable hardware, which includes flexible and highly instrumented photonic layer and coherent optics that can be tuned to a wide range of capacities, where the user only pays for what they need with software licenses. It delivers choice through open and disaggregated software architecture that allows operators to choose the elements that they want, so depending on whatever operational model that they have, if they want to use our software, if they want to use parts of our hardware, they have the choice to do that. And finally, this I think is the most important piece, is the simplicity that's delivered through advanced software apps that abstract the complexity that's associated with hardware flexibility. And this includes functions like integrated service and network management and planning application, network optimization, and predictive analytics. With that, I'll hand it over to Menwing.
Thank you, Helen. I would like to introducing the Fujitsu Intelligence Network ecosystems. The ecosystem, which contains the flexible hardware, the SDN controllers with orchestrators, as well as the intelligent applications that do all the heavy lifting for our customers. For the flexible hardware, Fujitsu is a pioneer on open modem systems to support a true multi-vendor optical network integrations. With Onefinity disruptive disaggregated hardware architectures, it allows the service providers to build the networks with the state-of-the-art components, as well as flexible transponders and programmable ROADMs. For controller software, Fujitsu's virtual network controllers and orchestrators allows the operator to control a multi-vendor network and get all the benefits of the software-defined network architecture. On top of all that, the Fujitsu Intelligent Applications Platform provides APIs that allow interworking with all vendor systems. It truly becomes a vendor-agnostic intelligent applications platforms that helps our customers to build the intelligent, efficient, and optimal networks. And my time to Mark.
Thanks, Menwing. At Infinera, when we look at software-defined capacity, we see a number of stages that are basically the stepping stones toward cognitive networking. Software-defined capacity started with instant bandwidth back in 2012. very successfully deployed with over 60 customers around the world. Customers like Telia Carrier used instant bandwidth to build their North American network and expand operations there and rapidly grow to be the #1 IP transit provider in North America. Instant Network, recently announced in March of this year, is a new set of models allowing software control of capacity in network. Telstra Global has been using our capabilities with their subsea network. And we're seeing Instant Network as the next step in a path of concrete steps to enabling cognitive networking, where the network is able to perceive problems in advance, recommend fixes for them, and essentially become more autonomous in its operation. Instant Network is a key step to enabling a cognitive network, and is important in that it enables a service provider's business model to eliminate over-provisioning of capacity by using software activation of capacity that is latent in the network. This is enabled by a combination of unique software capabilities and very unique hardware capabilities, and all these things together, software-defined capacity is for service providers so that they're able to more efficiently build out networks without spending a lot of money up front for idle capacity, being able to turn on new capacity with software without affecting services on the existing network. And through this acceleration of service delivery, we are increasing our service reliability because we're reducing the number of humans involved in it, and we're reducing our overall operational expense because we're automating the process of deploying this new capacity. So software-defined capacity end-to-end starts with instant bandwidth, today Instant Network, and is the stepping stones on the path to cognitive networking. Back to you, Heidi.
All right. Thank you very much, everyone. So let me do a quick wrap-up on our session. Again, if you're thinking of any questions, please enter them into the console. So from key takeaways today, I hope you learned a bit of a view on how we're seeing optical networks and optical network operations evolve moving forward. And fundamentally at the heart of this, it's this concept of shifting from being static or reactive in terms of operational models to becoming more dynamic and proactive in terms of how we manage and operate our networks moving forward. We explored a whole whack of some new technologies, new applications, and some of those key enablers. And hopefully you learned a few new things today. We covered capacity engineering, automated capacity engineering. We heard a little bit about the concept of instant bandwidth, real-time access to network data, how critical that is, how that fits in. Saw an example of spectral efficiency optimization and some really cool network health applications in terms of failure prediction and or moving towards proactive health within the network. So in summary, long journey ahead. We saw there's a lot of challenges that still need to be addressed before we go forward, but I do believe that the industry is aligned on a common vision on how optical networks are going to evolve moving forward and moving towards this concept of more intelligent optical networks. So with that, I'd like to shift over into the Q&A session. And we've already got a few good questions lined up here. So panelists, all prepared. I'll try and share them around. I'll start. I'm going to start with. We'll start in the technology piece first. So Helen, I'm going to fire on you first, and then we'll shift around a little bit. So Helen, there were. Let's see here. A couple of good questions with respect to adding programmable modulation into the network. So the first question that came in was, why would you not just put in as much capacity or just push the modulation and the symbol rates to get as much as you possibly can day one out of the network? Why would you only look to do that after the fact?
Okay, thanks, Heidi. And that's a question that I've received many times from different customers, and the answer is because maximum capacity changes throughout the life of the network. What's possible when a few channels are deployed in the network versus having a full fill of channels deployed in the network is very different. And so being able to adapt to the current network resources that you have, the current system margin that you have available to you, allows you to maximize capacity over the lifetime of the network for any point in time in the network's life.
Okay, and I would throw kind of one more related question to that. So if you're operating, and again for Helen, if you're operating in an environment where you can have this flexibility to change modulation formats around to adapt to different network requirements, doesn't that blow up what might already be going on with the data in the currently implemented modulation format?
Yes, so what we showed at the trial was that for any of the production traffic carrying on adjacent channels, traffic was not impacted there. But for the actual transponder that is going to be upshifted, you will, of course, get a short traffic hit. So either you live with that short duration in a second type of time frame, or you could take preemptive measures and move that traffic away before upshifting, which is what we've done in some trials as well, and then shift it back. There's different options depending on what the operational model is, depending on what the specific traffic is and the SLAs that are on that traffic that's being carried.
All right, great. Okay, over to Mark. I'm going to shift gears a little bit. So it's probably like a Mark Heidi question, but at the beginning I did introduce a little bit open APIs as being one of the considerations, one of those founding enablers to moving towards intelligent optical networks. And the question came up, and a very good question is, well, there are so many bodies out there today trying to, specify is a strong word, but trying to define what these APIs are. How do we move towards a more common set, or are we on the path to move towards a more common set? And Mark, I know you've got some opinions on this. Do you want to take a shot at that question?
You bet. It's really an exciting time in the telecommunications industry as software-defined networking has captured everybody's imagination. And one of the things we're seeing that's helping to accelerate this is the open community, the open source community, these communities of users, customers, vendors, suppliers that come together and then share information to be able to advance the state of the industry. And at this point in the industry, yes, we are seeing a plethora, a myriad, whichever big word you'd like to use, of open initiatives out there that are all trying to solve different problems. They're not all trying to solve the same problem, but there's often overlap. So what we're seeing in the industry right now is a harmonizing of these different open standards. As you look, these different agencies are starting to work with each other. And in terms of which open APIs to use, where it really comes down to, in terms of how we're seeing it today, what applications you're looking at. So, for example, if you're looking at carrier Ethernet, being able to turn on those services for your customers over an optical network, the Metro Ethernet Forum has done a lot of great work on MEF55, the Lifecycle Service Orchestration set of standards, open application programming interfaces, all designed for enabling carrier Ethernet. But of course, that's for that application. If you're looking at different applications, there'll be different groups that are focused on that. So at this time, I would say there's not one winning open provider. There's a lot of competing implementations out there. And what we've seen are things like the Linux project's Open Daylight has been strongly adopted across the community, including the folks over at AT&T with their own app project, integrating Open Daylight into that. So we think open is important. We don't think it has settled down yet. We think it'll be driven by the industry, and it's an exciting time ahead of us. Back to you, Heidi.
Oh, okay, great. So Mark, while I've got you, there's been a couple of questions that kind of are around the work Infinera is doing with instant capacity, instant bandwidth. And I guess some of the fundamental questions are, one, does it assume you have fiber to all the premises within the network? And I think the answer is yes, but maybe I'll get you to touch a little bit on sort of the path to getting there. But I think the other question that was asked a couple of times is, as you're looking to, or fundamentally, you do need to pre-provision some of the capacity. You have to have the fiber and provision the capacity to be prepared to turn up new capacity and services. So maybe just a little bit more on how you work with your customers on the business model for that. I know you touched on it a little bit, but maybe a little bit, just re-emphasize some of those points there.
You bet. So on the first part of the question about assuming fiber, definitely the instant network model that we talked about is all about the core of the network, really the long haul portion, the metro part. It's not really defined for activating capacity on access networks. And I'm sure we'll get there someday, but our core focus right now in terms of delivering concrete steps is in the core of the network, and there is generally fiber already there. And towards the notion of the second half of the question of pre-provisioning, you have to be able to have the capacity in the network to be able to software license it and turn it up immediately. And the difference with the Infinera approach is that we have these unique photonic integrated circuits that are incorporated in our infinite capacity engine that allow us to pre-deploy massive amounts of capacity without the customer paying for it in advance, so that the capacity can be deployed on existing fiber, but the bandwidth is not paid for until it is turned on. So yes, there needs to be fiber. Yes, there needs to be a piece of hardware there, but you don't have to pay for it in advance. You can software activate that capacity in your network. Back to you, Heidi.
All right, great, thank you. Okay, so I'm going to shift over to the applications for a second, and I've got a couple of questions for Menwing, and let's touch a little bit more with respect to where we're going with proactive network health, and in particular, just one of the components of that. So question is, Menwing, what are the differences between failure isolation and failure prediction? I wonder if you could describe that a little bit more.
Yeah, thank you, Heidi. So for the failure, the difference between the failure isolations and the prediction is that failure isolations help the operators to identify the issues and to isolate, to find the root cause. And today's, there is a way for doing the isolations, but then it still requires a lot of manual works that you still have to have people to work on those issues and knowing program it into the systems. But then for the intelligent ways that we're looking into is that all of these, it's being done in machine learning fashions. So the system will learn by just monitoring continuously for the PMs and the alarms comes in and different metrics, then they correlate them. So knowing the building maps to seeing that what the normal behavior is the networks, and then when the networks go over time, then they will see deviations. And that's how find the root cause, that's the isolations. Now, for the prediction, it's one step beyond the isolations. That once you isolate it, then you know that these are going to happen. Then when it's going to happen, it's very important. Then this is where the predictions that showing that then by analyzing, by seeing over time, and then the systems will be intelligent enough to tell when approximately it's going to happen. So then the operators or the service providers now that they can plan ahead of time and knowing that these things are going to happen, and so they can go ahead to order parts in advance. They can put these in place and get ready when they will start seeing that things are getting something abnormal, or that they would plan to at times that there are convenience for them, so then they're going out to switch out the systems to get to the minimal impacts of the networks. Thank you, Eddie.
All right, great. So here's just looking a little bit at monitoring real-time network parameters. Question came in, including things such as OSNR, FAC, bit error rate, and some others. What are the best parameters to monitor and why? And maybe, Helen, I could get you to answer, and Menwing and Mark, if you have any additional comments, maybe you can throw that in after. So Helen, I'll start with you. Helen?
Oh, thanks, Heidi. The most powerful parameter to monitor is prefect bit error rate. And then the others that you can monitor from the network are important parameters as well, like things like nonlinear noise measurements. All the data that you can gather will help to add color as to where the potential degradations might lie in the network. But the key and the most powerful parameter in my mind is the prefect bit error rate. And then you have to know what to do with it when you have it, and how to make intelligent decisions about what's happening in the network based on the data that you're receiving.
Okay, Menwing, do you have anything to add to that with respect to what you've seen from your experience?
Yeah, I think that we tend to agree with Helen that the prefab BERs is the most important parameters to look into, because for OSNR that you can really derive it from the BERs. And so once you have one form of information, then you will be able to get the rest of the information.
All right, great. All right, I've got one last question. I'll throw this over to Mark. There's quite a few questions with respect to the business models of moving towards instantaneous bandwidth or instant bandwidth, and just being able to add capacity into the network as a fly. So from a business or regulation comment, Mark, are there any points we need to keep in mind as we move forward?
Yeah, we often get asked, how can Infinera support this business model of deploying capacity that isn't paid for, that sits idle for some time, and then may or may not actually ever be activated, depending on the customer. And so, again, this really comes back to our ability with our photonic integrated circuits and the infinite capacity engine in our platforms to be able to pre-deploy a lot of capacity. And our business model is such that from a margin operational point of view, we're going to be able to ship that equipment, take the margin hit, only charge the customer for the capacity that they've activated. And then as that capacity is activated over time, the margin returns to us in the model overall. But essentially, there's no other obligation for the customer and no other regulatory issues in terms of them hanging on to it. So happy to discuss it more if anybody would like to chat about it. Give us a call. Thanks, Heidi.
All right. Thanks, Mark. Thanks, Helen. Thanks, Menwing, for your participation. We've reached the top of the hour. We still have a few questions that were unanswered, but we do track the questions, and we'll have our sponsors follow up as appropriate. With that, I'd like to thank the audience, and I'll hand over to Alan just to wrap us up.
Thanks, Heidi. I also want to thank you for leading our discussion as well, and also for all of our presenters today for this very in-depth and dynamic discussion. So an archived version of this webinar will be made available shortly, so feel free to come back and view it again or even share it with your colleagues. You're also going to see a short survey pop up at the conclusion of the webinar, so please take a few moments to fill that out. And lastly, just make sure you follow us on Twitter for information on future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.